Hello students, today we are going to see the combination of resistors, that is series combination and parallel combination. So let's start today's lecture. We'll start with resistor in series. So whenever these resistors are in series combination, you just remember that the current will be same throughout the circuit. Current will be same throughout the circuit. What it is basically saying that, let's say this one resistor R1, this one another resistor R2, this one another resistor R3. All are connected in series. Basically I am taking here 3 resistor. You can take as many as resistor. You can take n number of resistor also. Clear? So 3 resistor I am basically taking, and I am connecting this 3 resistor to a cell, right? It has potential V and I am connecting like this. And here you know that whenever this will connect in series, the current will be same. In R1 the current will flow I, through R2 the current will flow I, through R3 also the current will flow I. So instead of putting this R1, R2, R3, if I replace this R1, R2, R3 with a single resistor, then also there will be I current will flow through that equivalent resistor. What I am basically saying, instead of putting these 3 resistor, what I do now, I just put only one resistor, and I am saying that this is R equivalent of these 3 resistor. Right, same cell I am connecting, and I am saying that R equivalent resistor. Instead of putting R1, R2, R3, I am putting only one resistor, and it has the resistance value equal to R equivalent. Now same current will flow here, I current, because these 2 circuit are equivalent or same circuit. Now I have to find out how much this R equivalent will come. Just look at here. So you can say that if I apply the KVL loop here, you will say that you are going from minus to plus, so there will be a potential rise V, and you are going along the direction of the resistor, you are going along the direction of current through the resistor. So what will happen, there will be a drop in potential, that will be minus IR1, here it will be minus IR2, here it will be minus IR3, that will be equal to 0. That is KVL, basically loop law, right? So V equal to, I got I into R1 plus R2 plus R3. So current I will get V divided by R1 plus R2 plus R3 here. Clear? Now if I ask, can you find out the current here? You will tell the current here will be I equal to simply V by R. Or you can say that you can apply the KVL here also. You can apply the KVL here also. You will just apply KVL like this. You will say that there will be minus to plus, so there will be V. This will be moving along the direction of the current. So this will be minus IR is equal to 0. So current will be V by, this is R equivalent, right? V by R equivalent, right? So if you give this one as equation number 1 and this is equation number 2, so from 1 and 2, you can say that R1 plus R2 plus R3 is equal to your R equivalent, right? So whenever the resistors are connected in series, the equivalent resistance will be R1 plus R2 plus R3. Clear? If now I connect, let's say n number of resistor. Now if I connect n number of resistor here, this is clear, right? Let's say I am connecting n number of resistor. This is R1, R2, R3, R4, it is connected Rn, right? N number of resistor is connected like this. So can you find out equivalent resistance for it? You will say that equivalent resistance will be here R equivalent is equal to R1 plus R2 plus R3 plus Rn. Clear? This is your equivalent resistance whenever n number of resistors are connected in series. Clear? Okay. Everywhere, just a minute. Okay. So everywhere the current will be same in the series. That thing you have to remember. So let's do one question here. So if I ask you, this is 2 ohm resistor, this is 5 ohm resistor, this is, you can say that 3 ohm resistor, and it is connected to a cell having the potential, I can put here 20 volt, right? Can you find out the current through this circuit? You will tell that I have to convert, so you have to find out the current, right? How much current it is flowing here. Clear? You have to find out how much current is flowing through this circuit. You have to find out the I. So what you will do here, you just find out the equivalent resistance of 2 ohm, 5 ohm and 3 ohm. So you will find out the equivalent resistance. So you will tell the equivalent resistance R equivalent here will be 2 plus 5 plus 3 will be your 10 ohm. So instead of doing this one, I will say that I can put here only one resistor R equivalent, and that is your 10 ohm, and it is connected like this, and this is your 20 volt. Now you can easily find out the current. So you will tell that current equal to I equal to 20 divided by 10, that is equal to 2 ampere. Clear? This will be your current flowing through this circuit, you can find out. Okay, and you can do the problem like this. You have to find out the equivalent resistance and put it here and get the value, current value. Okay, now I am doing the same thing here again. Let's take 3 resistor I am putting. This is R1, this is R2, this is R2, this is R3, right? This is connected to a cell of potential V. Okay, what will be the current here? You know that current will be V divided by R1 plus R2 plus R3, right? This is your R equivalent. This much current is flowing through this circuit. Clear? Here also I current will flow, here also I current, everywhere the current is same. That is the series combination, that thing we have studied. Now I want to ask you, can you find out what will be the potential drop across this resistor? So I am writing here. So potential drop across R1 resistor, through R1 resistor, how much potential drop it will be. This thing we have seen, right? How much potential drop across the resistor, that is I into R, right? Here for R1 this will be I into R1, this will be I into R1. Clear? Similarly, potential drop across R2, it will be I into R2. Potential drop across R3 will be how much? I into R3. Clear? This much potential drop everywhere, right? Okay. Now I am asking how much power this R1 is consumed. So here I am saying power consumed by R1 will be how much? Power consumed by R1 will be I square into R, power is I square into R, this thing you know, power is what, I square into R, that thing I have to write here. So this will be, you will tell this will be I square into R1. So similarly power consumed by R2 will be how much, I square into R2. Similarly power consumed by R3, this will be I square into R3, right. This one you can write P1, this one you can write P2, this one you can write P3. Power consumed across or power consumed by R1 will be P1, power consumed by R2 is P2, power consumed by R3 is P3. Clear? This thing you can tell. Okay. Now I want to find out, can you tell me which power will be the maximum one? So you can say that you see three relation, I square R1, I square R2, I square R3, the power P1, P2, P3. I square is same for everyone, right? I square is same for everyone. So if I square is same for everyone, you will tell that power will be maximum for those resistors which resistance will be largest, right? So I can stay here one statement, you have to remember this thing, that power consumed by resistor will be maximum if the resistance will be maximum, right? If the resistance is maximum, then the power consumed by the resistor will be maximum. This thing very important, you have to remember, right? This thing you have to remember. Power consumed by resistor will be maximum if R is maximum, if the resistance is maximum, right? This is for the series connection, or this is for series combination. For series combination, you have to remember that, for series combination, you have to remember that the power will be maximum for the resistor which have the maximum resistance. Clear? You can find out, because I square value here everywhere it is same. Now second thing I want to ask you, here I is same everywhere, right? Or I is same, current is same here, this thing also you have to remember, right? These two things. So now do one problem here. So this is question I am writing. So let's say this is given as 2 ohm, this is given as 3 ohm, 2 resistor, and it is connected to a battery or cell that is 10 volt, right? The question is, find power consumed by 2 ohm, 3 ohm, 2 ohm and 3 ohm resistor. Second thing you have to find out, power delivered by the 10 volt cell, right? This cell has no internal resistance, this is, you can say that ideal cell I am taking, right? So power delivered by the 10 volt cell. So what you will do, you will say that in solution, power consumed by 2 ohm resistor. So I am writing P1, power consumed by, this is 2 ohm resistor. You know that this will be I square into R. So this will be I square into 2 ohm. So can you find out the current here? You will say that current I will be 10 divided by 2 plus 3, because 2 and 3 are in series. So this will be 5, 10 by 5 will be 2 ampere. 2 ampere current is flowing, right? So it will be I square into 2. I square will be 2 square into 2. How much it is? 4 into 2 will be 8 watt power, right? Clear? Then I am asking, find out the, just a minute, here I can write this one. Current is I is, here I am writing I is 10 divided by 2 plus 3. This will be 2 ampere. Clear? Now power through the 3 ohm, this will be I square into 3. So this will be 2 square into 3. This will be 4 into 3 will be 12 watt. Right? Now second question. Power delivered by the 10 volt cell. Right? How much power this cell is giving? So we will say that power due to the cell can be written as EMF into I. Right? Or potential drop across. Here it is EMF, the terminal potential same as here EMF, right? So that's why I am telling EMF into I, right? Or you can say that terminal potential into I, that thing we have seen, right? So it will be basically 10 volt into current is your 2 ampere, 2. This will be 20 watt. You see, this is power consumed by 2 ohm resistor is 8 watt, power consumed by 3 ohm resistor is 12 watt. If you add 12 plus 8, that will be 20 watt, and this cell is giving how much? 20 watt power, right? Power given by this cell is same as power consumed by these two resistor. Clear? Okay, this thing you see here. This statement also you just can verify here. Power consumed by the resistor maximum if the R is maximum. You see here, R is maximum for what? 3 ohm it is maximum. So if you put here, you are getting to 12 watt. Here you are getting 12 watt. Here you are getting 8 watt. Which one is bigger? 12 watt is bigger, right? So because the resistance here is the bigger. This resistance is 3 ohm, so this resistance is bigger. That's why the power consumed by the resistor will be maximum for the series connection. Clear? Okay. Next question, we'll see another question. What it is basically saying, this question is, let's say I am taking now a practical cell which has an internal resistance, let's say small r, and this has a EMF E, and it is connected through a resistor R. It is connected through a resistor R. Okay. Now you have to find out the current through the circuit, and you have to find out, first thing you have to find out the current, second you have to find out the power consumed by the resistor capital R, consumed by resistor R. Find the value of capital R so that maximum power consumed by the resistor R. So we have to do 3 questions here. First one is that find out the current value here in this circuit, and power consumed by the resistor R, and find the value resistance R so that the maximum power consumed by the resistor. So you have to find out a value of capital R so that it will be consume maximum power, right? Okay. This thing you have to find out. So I am doing the solution here. Just see here. First of all, you will tell that though this is the internal resistance of the cell, but this resistance and this resistance are connected in series. Here it is connected in series. So what I can say that I can replace this thing as one resistor, that R equivalent, I am just writing here, R equivalent will be how much? R equivalent will be basically capital R plus small r, right? And you can easily find out the current. I will be how much? E divided by R plus R. This is same thing, right? Instead of putting small r, we put there R1, R2. You just see the same thing we will get, right? This will be E divided by R plus R. You can remember this also, because whenever you see this type of situation, you can say that current will be EMF divided by capital R plus small r, right? Now second thing, this is first one is solved, right? Second thing, it is telling that power consumed by the resistor R. So power, you know that, so I am writing power is can be written as I square into R. So I will be how much? E divided by R plus small r whole square into R. This much power is consumed by this resistor capital R, right? Now come to the third question. This is clear, right? First of all, what we find out? I find out the current. How I find out the current? I am telling here that this resistance and this resistance are connected in series. If they are connected in series, then how much current it will flow? You will say that EMF divided by R plus R current will flow in the circuit, right? And current value we got. Then I have to find out how much power dropped here. How much power dropped, or how much power consumed by the resistor R. You will tell that power consumed by the resistor R is I square into R. So if this is I square into R, I can write I value is E divided by R plus R whole square into R. Clear? Okay. Now I have to find out the value of R so that the power consumed is maximum. So if the power consumed is maximum for value of R, what I can do for maximum, you know that I have to do derivative. So I can say that dP by dR should be equal to 0. Then I can find out the value of R corresponding to which the power consumed will be maximum. Okay. So can you find out dP by dR here? So you will say that d by dR, this P value E square divided by R plus small r whole square into R, right, equal to 0. Clear? This thing I have done. So this is, you can take this is x into y, like that you can take product formula. So you will say that d by dr, first thing you can take constant here as r and derivative of E square divided by R plus R whole square, plus take this one as a constant outside, E square divided by R plus R whole square. This will be d by dr of R. Clear? This should be equal to 0. Basically what I use here, which formula I use? If I write here, this will be d by dx of y into z. So this will be y divided by dz by dx plus z, this will be dy by dx, like that we can write. Clear? This formula I have used. So you just see here what will come here. This will be r, E square is constant, you can take it out, d by dr of 1 by R plus R whole square plus E square divided by R plus R whole square. dr by R is simply 1 is equal to 0, right? So this is R E square, d by dr of, you know that how to do this one, you will say that this will be R plus R whole 4, and here it is, first one you have to take R plus R whole square but this should be derivative of 1 d by dr, and this should be 0, right? Derivative of dr will be 0 here. This thing you know, derivative of dr, if I write, this will going to be 0. This will be square derivative d by dr of 1 minus 1 into d by, this thing I am writing here, just a minute, here I am writing. So this should be r e square, because this place is occupied here, so this will be, I can write r plus r whole 4 into r plus small r whole square into d by dr constant 1 minus, you can say that 1 into d by dr of r plus r whole square. Clear? This will come plus e square divided by r plus r whole square is equal to 0. Right? So this will be 0 basically. So you will say that this will be r e square. So this term, full term will be, this one is 0. So this will be 0 minus, if you see here, this will come 2r plus r, right? Divided by r plus r 4 plus e square divided by r plus r whole square is equal to 0. Now you can see here, this will be 1 r plus r, 1 plus r, r plus r will get cancel out. There is 1 minus, so that I will take this side to this to right side, right? So it will be coming as r e square. This will be 2 divided by 1 will get cancel out here. So this will be your r plus r whole cube, right? And this should be equal to here e square divided by r plus r whole square, right? I am doing step by step, that's why it is take too much of time. Or you can, if you are expert in derivative, you can find out directly here, right? You can directly find out here. Okay, so you see here, so e square get cancel out, and you will say that, and 3 and 2 get cancel out, only r plus r will be here. So I can directly writing 2r equal to r plus r, right? I am taking to that side. So here it will be r equal to small r. So one thing you got that here, when the power consumed will be maximum through this resistor R, you will tell that whenever this capital R resistance is equal to the small r, that is internal resistance of the cell, then that time or for that condition only there will be power consumed by this resistor will be maximum, correct? So here when will be power consumed maximum? When R equal to your capital R equal to your small r, then only the power consumed by this resistor capital R will be maximum, right? Okay, this thing we have seen. So this thing you have to remember here. This is one important statement, and question asked from this statement directly. If you remember, then you can do it very easily. One line you have to read and just to say for which resistance the power will be maximum. You don't have to do the derivative and all this thing. Clear? This is the question, right? Here read that question. So a battery of EMF 10 volt and internal resistance of 0.5 ohm. So this is the battery of, this is 10 volt and internal resistance is 0.5 ohm, is connected across a variable resistance R. So it is connected to a variable resistance R, right? This they have given. The value of R for which the power delivered in it maximum. So they are asking for what will be the value of R, so that the power consumed by that R will be maximum or power delivered by this R will be maximum. Obviously you will tell that now this thing we have seen, right? If this is 0.5 ohm, if capital R equal to small r, then only it will deliver the maximum power, right? So you see which option it is. So you can say that this will be option number 1. So whenever the internal resistance of the cell is same as the resistance capital R, there will be power loss or power consumed by the resistor will be maximum, or power delivered by the resistor will be maximum. Clear? Now this is second question. A 6-volt battery is connected to the terminal of a 3-meter long wire. So this is a 3-meter long wire. This length is 3 meter, and this is connected to a 6-volt battery, right? And they are connected terminal of 3-meter long wire of uniform thickness. So it has uniform thickness and resistance is 100 ohm. So it's 3 meter and resistance they have given 100 ohm, right? The difference of potential between 2 points on the wire separated by a distance of 50 centimeter will be. So let's say this is 1 point and this is 1 point. The distance between them is 50 centimeter. You have to find out the potential drop across this resistance, because it's a big resistor, right? 3-meter long wire and this has 100 ohm resistance. For 50 centimeter length from this wire, you have to find out how much potential drop will be here. So first of all, to find out the potential drop here, you have to find out how much this resistance is actually here, because this is a big resistor and this is a small resistance. If I say here, how much resistance it has, so you can find out very easily. You will tell that for 3-meter long the resistance is 100 ohm, right? Clear? So 3 meter is, I can say that 300 centimeter, it will be 100 ohm. For 50 centimeter, it will be 100 divided by 300 into 50 ohm, and this will be 50 by 3 ohm. So here the resistance, the value will come 50 by 3 ohm. Clear? Now can you find out how much current it will flow through this? You will tell that this long wire has resistance of 100 ohm. So the current here will be 6 divided by, the current will be 6 divided by 100 ohm. Right? This is big resistor here, 100 ohm. So the current will be same everywhere. So this will be 6 divided by 100 ohm. Sorry, ampere. Right? This much current will flow in it. Now you have to find out the potential drop here. You can find out. So potential drop V I am writing. So V will be how much? Here the potential drop is V. V will be, you will tell simply I into R. So I is how much? 6 by 100 into R is, you got for this length 50 centimeter length, this will be 50 by 3. So this will be 2, this will be 2. So 2 get cancel out, this will be 1. Right? Clear? So 1 volt, right? 1 volt will come as here potential drop across this 50 centimeter. Basically, in other way you can calculate this one. What you will do basically, here I am just making this 50 centimeter, right? So I can make 6. This is 1, 2, 3, 4, 5 and 6. 6 resistance I can make, because each have 50 centimeter, 50 centimeter, 50 centimeter. I can make with, from the 3 meter length I can make this resistance, and each having the resistance same, because all has the same cross section and same everything, right? And this is your 6 volt battery and it is connected like this, right? I just divide this 3 meter long resistance to only this 6 resistance, right? This 3 meter is make part wise, and this is R 6 resistance, equal resistance you can put. And this is 6 volt battery is there, and current will be same here because all are connected in series, right? So you will tell that whatever potential drop here through this R, this will be Ri, here also 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 Ri. Clear? Everywhere the potential drop will be Ri. If everywhere the potential drop is R into I, right, this will be 6 Ri potential drop, and 6 Ri potential drop is basically your 6 volt. So Ri will be how much? Ri will be 1 volt. You can calculate this one easily without calculating all these things. That's what I am telling you, right? You can do this way also, or you can do this way also. Without calculating all this, how much resistance will come, how much it will come, you don't have to calculate. You can do like this, you can get the answer also. So what will be your option? So 1 volt, right? Okay. Now see this question. Two metallic wire of identical dimension are connected in series. So two metallic wire of identical identical dimension means what? Their length is same and their area also same, right? So let's say there is two identical. I am taking this is one conductor and another conductor is this one, right? And if it has length L, it also has length L. It has area A, it also has area A. Clear? Now sigma 1 and sigma 2 are the conductivities of these wires. So this is sigma 1 conductivity, this is sigma 2 conductivity. The effective conductivity, so they are asking find out the equivalent conductivity for the combination. What you do now? You will tell that you just combine these two. If you combine these two, let's make only one wire, and this one wire has the area is same but the length will be now 2L. Clear? So it is connected in series. If you connect these two in series, this will form. Clear? So what we can do now, for series connection, I know that if I am taking this is R1 resistance, I know this is R2 and this is your R equivalent, let's say. So I am writing here R equivalent equal to R1 plus R2, right? R equivalent equal to R1 plus R2. So here I can write R equivalent can be written as rho, that is resistivity, into 2L, right? R equivalent, this will be 2L length, right, divided by A, is equal to R1. For R1 can be written as rho 1, this is your sigma equivalent, right, or sorry, rho equivalent, rho 1 into length L divided by area A plus rho 2 into L divided by area A. Clear? So you see here L by A everywhere get cancel out. So you can say that 2 into rho equivalent equal to rho 1 plus rho 2. You can write. And they are asking about the conductivity. What I can do? I know that reciprocal of the conductivity is resistivity, right? So here I can write that 2 by sigma equivalent is equal to 1 by sigma equivalent, sigma 1. This will be plus 1 by sigma 2. Right? See here what I can write from 2 by sigma equivalent, this will be sigma equivalent, right? So 2 by sigma equivalent equal to this much. So I can write 2 by sigma equivalent is equal to, here it will be sigma 1 sigma 2, this will be sigma 1 plus sigma 2. So sigma equivalent is basically 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2. So this will be your equivalent conductivity, right? So you see which option it is matching, 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2. So which option it is matching? So option number 1 it is matching, right? 2 sigma 1 sigma 2 divided by sigma 1 plus sigma 2. Clear? Now next question, the internal resistance of 2.1 volt cell which gives a current 0.2 ampere through the resistance of 10 ohm each. So you have to find out the internal resistance of the cell, right? So what they are telling, so this is your 2.1 volt cell, right, which gives a current of, this is the internal resistance, which gives a current of 2.2 ampere through a resistance of 10 ohm. So this is your 10 ohm resistance, and how much current it is giving? 0.2 ampere current they have given, right? So you have to find out this R. How will you find out? So you know that current can be written as 0.2 equal to 2.1 divided by R plus here this R, this thing, right? Current equal to E divided by R plus capital R. This formula we have seen here, right? Here we have seen this one. Here, right? E divided by R plus R. Same thing you can apply. Okay. So how much it will come? You will tell that 0.2 into R plus 2 equal to 2.1. So 0.2 R equal to 0.1. So R will be 1 by 2. That will be 0.5 ohm. Clear? So which option will be correct here? So R will be D option, it will be correct. So R value you got 0.5 ohm. Okay. Now go to this question. A current of 2 ampere flow through a 2 ohm resistor when connected across a battery. The same battery supplies a current of 5 ampere when it is connected across a 9 ohm resistor. The internal resistance of the battery they are asking. So what it is telling that, if this is the one circuit and this is the internal resistance, and it is connected through a 2 ohm resistor, right, across a battery. So current is flowing 2 ampere. Clear? The same battery supply a current. So same battery means the internal resistance is not going to change. This whatever EMF here, it also not going to change, right? The same battery supplies a current of 5.5 ampere when it is connected across a 9 ohm resistor. Now it is 9 ohm resistor, and it is providing how much current? This will be 0.5 ampere current here. Now you have to find out the R value. So you can say here that 2 ampere is basically I equal to EMF divided by 2 plus R, right? Same formula. Here whatever we will get, 0.5 is equal to E by 9 plus R. Clear? This much you will get. So I have to find out the R, right? So I just replace this EMF here. So I can do here 0.5 equal to EMF value I can write 2 into 2 plus R, right? So it will be 2 into 2 plus R. This will be, can be 2 into 2 plus R divided by 9 plus R. Okay. So just multiply here. So this will be 4.5 plus 0.5 R is equal to 4 plus 2 R. This much will come, right? So you take this one to this side, this will be 0.5, 4.5 minus 4, and this will be 2 minus 1.5. So this will be 2 minus 0.5 will be 1.5 R. So R will be 0.5 divided by 1.5. This will be 5 by 15. That will be 1 by 3. Right? So R equal to 1 by 3 you got. So which option will be correct? Option number 1 will be correct here. Clear? So the same formula we are using here, what is that formula? You have to remember, wherever you will see this type of circuit, current in the circuit equal to E divided by capital R plus small r, right? If you remember this one, you can solve this formula very easily, solve all this problem very easily. Now we will see resistors in parallel, right? So resistor in parallel means, let's say this is your R1 resistor, this is your R2. I just make it little bit wider. this is your R1, this is your R2, this is your R3. I am taking 3 resistor and I will generalize for n resistor, and it is connected to a cell, right, of V potential. Clear? So I have to find out the equivalent resistance for these 3 resistors which are connected in parallel. Clear? What I will say, I have to convert it to a equivalent resistor, that is your R equivalent, and this is connected like this. Clear? I current will flow here if this is your V, and here also I can tell that I current will flow here. But all are connected in parallel. So in parallel combination, you have to remember that potential is same. Their current is same, their potential is same. Potential same. Because the potential between these two terminal will be V here, here it will be V, here also it will be V, here also it will be V. So everywhere potential drop will be same. Clear? And whatever the current will flow here, it will divided here. Let's say here I will tell I1, sorry, this is R3, right? I can say that I3 current is going, here it is I2 current is going, here it is I1 current is going. Clear? And I3 plus I2 plus I1 is equal to I. That is, you remember that is your what? That is your KCL, right? The current, if you take this one as a junction, here I3 current is flowing, here I2 plus I1 current is flowing along this direction. So here it will be I2 and here it will be I1, right? So I equal to I3 plus I2 plus I1. So what I can write here? So I equal to basically I1 plus I2 plus I3. Can you find out the I value here? You can find out I value here. So you will say that the current flow here will be V divided by R equivalent is equal to, what will be the I1? You will say that I1 current can be find out if I know that potential drop between these 2 points. If I find out the potential drop between these 2 points, I can find out the value of I1, right? So you know that if it is connected in parallel, whatever potential drop these 2 points, the same potential drop will be here. So V potential drop will be here. So you will tell that I1 can be written as V by R1 plus same again I2 current is flowing along this resistor, R2 resistor. So here the potential difference is V. Here also the potential difference is V, because the potential is same when it is connected in the what? Connected in the parallel. So you can say that I2 equal to V by R2. Similarly I3 you can find out same potential drop here and here. This will be V by R3. So everywhere V cancel out. So 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. This you can find out. Clear? In this way you can find out. This is equivalent resistance for connection in parallel, right? Or combination of the resistor in parallel way, right? Parallel combination. Okay. Now can you tell me what will be the potential drop across R1? So here I am writing potential drop across R1. Across R1 potential drop will be how much? You will say that same V, right? This will be V, and that will be equal to how much? I1 into R1. Similarly, potential drop across R2 is equal to same V. This will be I2 R2. Similarly, potential drop across R3 is V. This will be I3 R3. Clear? So I can write I1 R1 equal to I2 R2 equal to I3 R3. Okay, this is the potential drop. Now I want to find out how much current is flowing here in terms of this current. If instead of putting 3 resistor R1, R2, R3, if you put a equivalent resistor, then also I current will flow. Here also 3 connection you made, and here it will I current will flow. Net current is I, it will flow. So I want to find out the current I1, current I2, current I3 in terms of current I. Clear? So how I will find out? You will say that I want to find out, let's say I1, right? So you will tell that I1 is basically V by R1, and V is how much? This potential can be written as, how you can write potential? So potential can be written as R equivalent into I, right? R equivalent into I. So here I can write this is R equivalent into I divided by R1, because here you see here V equal to this, from this I can V equal to I into R equivalent, right? This thing I have written V by R equivalent, I equal to V by R equivalent, that thing I am putting here. Clear? I1 equal to V by R1, that is equal to R equivalent I by R1. So what will be the I2? I2 you will tell that this will be V by R2, that will be again R equivalent into I divided by R2. Similarly, can you find out I3? This will be V by R3 is equal to R equivalent into I divided by R3. So this thing you have to remember, right? So current through any resistor, you can find out R equivalent of the parallel combination into the net current which it is flowing divided by R1. Clear? In this way you can find out, right? Now one more thing I want to tell here. Can you find out potential drop? Or sorry, power consumed. So power consumed by R1 will be how much? Power consumed by R1. We will tell that power consumed by R1 will be V into I1, or you can say that I1 square into R1. You can apply any formula, but here basically in parallel combination the potential everywhere is same, right? So we can write V into I1, or you can write V square by R1. So that will be, which one will be more convenient for you? More convenient for you will be V square by R1, because V is everywhere same. So you can write V square by R1. So you can write power consumed by R1, that is you can write power consumed by R1 is your R1 is equal to your P1, right? That can be written as V square divided by R1. So similarly power consumed by R2, that will be your P2, that can be written V square by R2. Similarly power consumed by R3, this will be V square by R3, because power formula we have seen, right? For power formula we have seen 3 formula: power equal to V into I, power equal to V square by R, power equal to I square into R. 3 things we have. You have to see which formula will be easy to apply in the circuit, right? In series it will be I square R will be very easy to apply because current is same everywhere. In parallel the voltage is same everywhere, or potential drop will be same everywhere. So if the potential drop is same, so you can directly say that this formula will be easy to apply, because resistance value it is known to me, and V square by R1 you can put directly. Clear? So this will be V square by R3. Now can you tell me which one will be the maximum power consumed? Which resistor is consuming maximum power? Here what I am saying that which resistor is consuming the maximum power. So you will tell that the resistor will consume maximum power which has the less resistance or very smallest resistance value. So I can say that power consumed will be maximum for R minimum, right? Whose resistance will be minimum, that resistor will consume more power or that will dissipate more power. This is very important thing you have to remember. For parallel combination, the resistor which have the less resistance or smallest resistance, that will consume more power. For series case, the resistor which have the maximum or largest value of resistance, that will consume maximum power. Clear? This thing you have to remember. If you remember this thing, you can do easily some questions, right? These two concepts you have to remember. Okay. And this current formula, it also you have to remember, right? You can find out current through any resistor in the form of the net current which is flowing. I is the net current it is flowing, right? So R equivalent I divided by R2. This way you can find out. Okay. Let's do one problem. So this is 2 ohm. I just have to put in, this is in parallel. This is 3 ohm and it is connected like this, right? Let's say I am putting here 10 volt again. Can you find out the current here? Find out I, find out I1, find out I2. All this value you have to find out, right? So you can easily find out I1 and I2 here. So what you will tell that I1 can be find out V by 3 ohm. Sorry, V by 3 ohm. How will find out? So why this is V? So how much potential will be here? So you will tell that if this is 10 volt, here also drop will be 10 volt. So I1 will be 10 divided by 3 ampere. I2 will be how much? If this is 10 volt, here also it is 10 volt. So 10 divided by 2, that will be 5 ampere. Clear? And you know that I can be find out I1 plus I2, that will be 10 by 3 plus 5, total this much ampere. Clear? In other way also you can find out the I value. How will find out? You will say that make the parallel combination. If this is 2 ohm and this is 3 ohm, I can make it to only one resistor, and the equivalent resistance will be how much here? R equivalent. So you will tell that 1 by R equivalent is equal to 1 by 3 plus 1 by 2. That will be 6. This will be 2 plus 3. So R equivalent will be 6 by 5 ohm. Clear? This will be here 6 by 5 ohm. And here it is 10 volt. Now can you find out the current? Here it will be I current will flow. I will be 10 divided by 6 by 5. So it will be 50 by 6. You add here. If you add here, how much you will get? 10 plus 15 divided by 3, that will be 25 by 3, or this is same, right? 25 by 3, this you cut here, this will be 2 cancel out, this will be 25 divided by 3. See here, it's matching here, right? Got it? Second thing, current value you got. Second thing you have to find out, can you find out the power consumed by 2 ohm resistor? So power consumed by 2 ohm resistor. So you will tell here that power consumed by 2 ohm resistor, I am writing here, let's say this is 2 ohm resistor, I am writing P2, right? Because the current is flowing I2, P2 I am writing, will be how much? P2 equal to, you will write V square by R2. That will be, V will be how much everywhere? 10 volt. So this will be 10 divided by 10 square divided by R2 will be how much? R2 is your 2 ohm. So this will be 100 divided by 2, that will be 50 watt. Now can you find out the power consumed by the 3 ohm resistor? So power consumed by 3 ohm resistor, so you will tell that P3, that is power across the 3 ohm resistor, is equal to basically V square by R, right? Or V square by, I am directly writing, this is your 3 ohm, right? V square by 3. So V is how much? 10 square divided by 3. So this will be 100 by 3. So 100 by 3, approximately it will be 33.33 watt. You see here, which one is consuming more power? You will say that 2 ohm resistor is consuming more power, because 2 ohm resistor has less resistance value. You see here that thing, power consumed maximum for R minimum, right? Power will be consumed by the resistor will be maximum when the resistance will be minimum. So you see here, minimum resistance between these two is 2 ohm, so it will consume more power. Clear? This will be 50 watt. Same concept. Why I am giving so much of importance to this power consumption? Basically because this thing we are going to do some with this, with depending on this thing we are going to do some problem on the bulb basically, right? So bulb problem we can do with this thing. Clear? Okay, this is done, right? Now do this question. 3 resistors having resistance R1, R2, R3 are connected as shown in the given circuit. The ratio of I3 by I1 of the currents in terms of resistance used in the circuit. So here you can directly apply this formula, right? This formula, and you can find out the value. This I1 equal to R equivalent I by R1. We'll see how to use this one, right? So you will tell that I1 current is flowing in it, right? I1 current is flowing in it. Okay, or I can do here some example, then it will be clear, na? In this question I will do something, then it will be clear to you. So here I am writing it. You got the I value, I you got how much? I equal to, you got 25 by 3 ampere. I1 value how much you got? I1 you got how much? 10 by 3 ampere. And I2 value you got how much? Here 5 ampere. Clear? So this thing I can show you in another way, this by this formula. This formula I can show. So I1 is equal to R equivalent I by R1, right? So I can say that I1 is equal to I into R equivalent divided by R1, right? Clear? This is, you can take R1, this one you can take R2. To use this formula I am just writing. So this will be, I will be how much? 25 by 3 divided by R1, and R equivalent will be how much? R2 and R1, they are in parallel, so it will be R1 into R2 divided by R1 plus R2, right? Clear? This thing, R equivalent equal to 1 by R1 plus 1 by R2, this thing you just calculate, it will be R1 R2 divided by R1 plus R2 will come. Clear? So R1 got cancel out, this will be 25 by 3 into R2 divided by R1 plus R2. So this will be 25 by 3 into R2 value is how much? 2 ohm divided by 2 plus 3 R1 plus R2. So this will be 5 cancel out, this will be 5 by 3 into 2, that will be 10 by 3 ampere. You see here, you are also getting 10 by 3 ampere. So with this formula you can find out. Similarly, you have to find out the value of, you can find out the value of I2 also. You just for I2, I will write the formula, you can calculate and verify. I2 equal to how much? I into R equivalent divided by your R2, right? Divided by R2. This will be your I2. I into R equivalent divided by R2. This you can find out. And obviously that will come as 5 ampere, correct? Now see here. Now I3 by I1 you have to find out. This is I3 here. So I just take a black pen. Here it is I3 they have given. Here it is I2. They have given this is I2. And this is your resistance R2. Here it is resistance R3. Right? This resistance is R3. This resistance is R2. This is your R2. This is your R3. Right? And here it is flowing I1 current. This is your R1 resistor. Right? So can you find out the value of I3? So you will tell that I3 can be find out. I3 is equal to, I1 current is flowing along this direction. So you will say that I1 into R equivalent divided by your R1, because sorry I3 you are finding, no? R3 you have to write, right? So I3 will be I1 into R equivalent divided by R3. So this will be R equivalent will be how much here? We will do in another way also, because this will be very easy. You will get the answer very easily, because that will be directly relating the I1 and I3. That's why I am doing. So R equivalent will be which one? R2 and R3 are connected in parallel here. R2 and R3 are connected in parallel. So you will say that if this R2 and R3 are connected in parallel, what will be R equivalent? This is your R2 and this is your connect R3. R equivalent will be 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Clear? So it will be coming as R1 R2. This will be R1 plus R2. So R equivalent is equal to R1 R2 divided by R1 plus R2. Clear? You can remember, if two resistors are connected in parallel, the equivalent resistor will be R1 R2 divided by R1 plus R2. So it will be, here it will be, sorry, they have given R2 R3, now we have taken this is R1 R2. So you can replace here, I am just writing. So this will be R2 R3, right? So 1 by R equivalent is equal to 1 by R2 plus 1 by R3. Clear? So R equivalent will be how much? R2 R3 divided by R2 plus R3, right? R2 plus R3. R2 plus R3, R2 plus R3. This will be our R equivalent when they are connected in parallel. So you see here, this will be R2 R3 divided by R2 plus R3 into R3, right? So here you have to write everywhere small. This will be R3, right? So R3 get cancel out. This will be I1 into R2 divided by R2 plus R3. This will come, right? So you see here, what will be the option? I3 by, they are given I3 divided by I1 is equal to how much? R2 divided by R2 plus R3. R2 plus R3. This will be your answer. You see here, which one will be? R2 divided by R2 plus R3. This option, right? R2 divided by R2 plus R3. Or in other way also you can find out this relation. Right? If I1 is flowing along this direction, I1 is equal to I2 plus I3. Right? Clear? And here the potential drop will be same. But because both are in your parallel combination. So whatever potential drop here, the potential drop will be here. Clear? That way you can find out. Okay. Now go for this question. The effective resistance of a parallel connection that consists of 4 wires of equal length, equal area, equal cross section and same material is 0.25 ohm. What will be the effective resistance if they connected in series? Right? What they are telling you, just see. The effective resistance of parallel connection that consists of 4 wire of equal length. So 4 wire means each have the same resistance. All are connected in parallel. Right? Same material is 0.25 ohm. Right? The effective resistance. So if I take this is R, this is R, this is R, this is R, and I make it to only one resistor, they have given this one is 0.25 ohm. Right? This is your R equivalent. So can you find out R equivalent? R equivalent, or you can say that 1 by R equivalent is basically equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So basically here each resistance is same. So you can head here. So this will be 4 by R. So this is 4 by R. So you can say that R is equal to 4 into R equivalent. And R equivalent, you know that this is 0.25. So it will be coming as 1 ohm. So each resistance will be 1 ohm. This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm. Now they are telling that what will be the effective resistance if they are connected in series. So each 1 ohm resistor you connect now in series. This is 1, this is 1, this is 1, this is 1. This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 1 ohm. Right? This is 1 ohm. If you connected in series, you know that in series connection that equivalent resistance will be what? R1 plus R2 plus R3. So R equivalent will be R plus R, or I can write here 1 plus 1 plus 1. Right? I am directly writing 1 plus 1 plus 1 plus 1. So this will be 4 ohm. Clear? So this option 4 will be correct. Right? This will be 4 ohm. Clear? And do this question. The equivalent resistance between A and B for the mesh shown in figure. I hope this is clear to you, or I can write here. This is basically one resistor they have given. Now I think this will be clear. Right? This is basically 4 ohm. This is 4 ohm. Here it is 8 ohm. This is also 8 ohm. And this is basically 6 ohm, right? This thing you have to find out, the equivalent resistance between A and B. So how will find out this one? So we will tell that this 4 ohm resistor and this 8 ohm resistor, they are in series, right? They are connected like this. So what I can say here, that it will be 4 ohm. Here I am doing a, let's do here. So this is your 4 ohm and here it is 8 ohm disconnected. This will be your 6 ohm and it is connected like this. This will be your 4 ohm and here it is 8 ohm. This point is your A, this point is your B, right? From here what you can say, this 4 ohm 8 ohm are in series, so equivalent will be 4 plus 8 will be 12. This will be 12 ohm. Now here it is connected to 8 ohm resistor, right? And it will be like this. Step by step we are going. This will be A, this will be B. Now 12 ohm and 8 ohm are in parallel, so you can say that only one resistor I have to write and this will be connected like this. This resistance will be equivalent of 12 ohm and 8 ohm. And here it will be 4 ohm and here it will be 8 ohm, right? This will be your 4 ohm, this will be your 8 ohm. We are coming from here, so 12. So how much it will find? You just apply that formula, 12 into 8 divided by 12 plus 8, that will be 20. So it will be, you can say that if you cancel with 4, this will be 24 divided by 5, right? This much will come, right? So this will be 4, 2, this will be 5, yeah, this will come. So this will be 24 divided by 5. Okay, now all are in your series, right? All are in now series. So all are in series means you can write 4 plus 24 by 5 plus 8. So this will be 12 plus 24 by 5. So this will be 60 plus 24 divided by 5, right? So it will be coming as something we did mistake. No, right? Oh, this is 6 ohm, na? We did mistake here. This is not, this is 6 ohm, sorry. This is 6 ohm, not this one. We just take 8 ohm, I just take this, maybe this is 6 ohm. So if this is 6 ohm, you can say that this is 12 into 6 divided by 12 plus 6, right? So it will be 12 into 6 divided by 18. So this will be 3 and this will be 4 basically. So this will be 4 ohm now. So all are connected in series now. So you can say that 4 plus 4 plus 8 is equal to 16 ohm, right? So you check option here. Which option will be correct? Option number 2 will be correct, right? So you can do this for, you just make this type of circuit. From here you just make two equivalent of 4 ohm and 8 ohm in series. This will be 12 and 12 and 6 are in parallel. Then you can get one equivalent resistance and you can calculate like this. Clear? Now let's go to question. A wire of resistance 12 ohm per meter is bent to form a complete circle of radius 10 centimeter. Okay, the resistance between its two diametrically opposite point A and B shown in the figure is. So I just draw it this one. So this is your one circle, you can say. This is made up of conducting wire and this point is basically your A and this point is basically your B. Okay. So this wire has resistance of 12 ohm per meter. So per meter the resistance is 12 ohm, right? And bend to form a complete circle of 10 centimeters. So you can find out the length of the wire. So length of the wire L you can find out is 2 pi r, right? Because it's form a circle, if you open it, it will be a straight line, that length will be 2 pi r. So it will be 2 pi into r value how much? 10 centimeter, 10 into 10 to the power minus 2 meter. Got it? So it will be 0.2 pi, right? This much length in meter. Okay. So resistance is 12 ohm per meter. That means for this length how much resistance will be there? So you will tell that resistance will be 12 ohm per meter into this 0.2 pi. Got it or not? So this will be 2.4 pi ohm. The resistance will be this much now. Got it? Because per meter the resistance is 12 ohm per meter, and for this much length the resistance will be 2.4 into pi ohm. Clear? Now this full length has this much resistance. Now A to B, this A to B, right? A to B will be half length. So here to here, if I say you, here to here, the length will be how much? From here to here. If this total length is 0.2 pi, here this length will be 0.1 into pi, and here also the length will be 0.1 into pi, right? Half circle you can say, right? Perimeter of half circle. Now I have to find out the equivalent resistance. So if this is 0.1 pi, and I can assume that this one and one resistance here, and how much this resistance value will come? You will tell that this resistance will be 12 ohm per meter is the resistance of what? 12 ohm is the resistance of 1 meter, and 0.1 meter will be how much resistance? So we will say that 12 into 0.1 pi, and here also you can say this is one resistance, this is one wire, and this is also 12 into 0.1 pi, 12 into 0.1 pi. Clear? So this thing you can draw now. This is your point A. With through this point, about this point you have to find out the resistance value. So you will tell that this is your point A, and here you have connected one resistor. This is your point A. Here you have connected one resistor. Here you have connected one resistor. That will be 12 into 0.1 pi, and this will be your point B here somewhere. This is your point A. This is your this is your point A. This is your point B. Clear? And this one again, this will be 12.0.1 pi. So what will be the R equivalent? Both are in parallel. If both are in parallel, you can say that if this is R1 and this is your, again this is also R1, right? The R equivalent will be what? You know that R1 into R1 divided by R1 plus R1. So this will be R1 divided by 2. Clear? If this is R1 divided by 2, so you can say that R1 value is 12 into 0.1. So this will be 12 into 0.1 pi divided by 2. This will be 0.6 pi. Got it? I am taking this R1 value 12 into 0.1 pi. Then I just calculate, this is R1 divided by 2, that means 0.6 into pi. So you check the option. So this will be option number 1 will be correct, right? 0.6 into pi. So basically 12 ohm is the resistance per meter. Clear? So this length is 0.1 pi. That means what will be the resistance of this? 12 into this much. Per meter has 12 ohm resistance. 12 into 0.1 pi will be has resistance for this length 0.1 meter. Got it or not? This is 0.1 meter, you can see. This is 0.1 meter. Got it? This will be the resistance value. Here I can write R1 value this one, R1 value is this one. And here you have written R1, R1. Got it? Okay. Now go to the next question. Here we are doing very slow because you are first time you will do this problem. That's why I am going very slow here. When a wire of uniform cross section A and the length L and the resistance R is bent to a complete circle. Okay. So cross sectional area is A given, length is L. So length is L they have given, and a resistance is R they have given, is bent to form a complete circle. So they have made a complete circle like this. Okay, though it is not looking like a circle, you just imagine this is a circle, right? The resistance between any two diametrically opposite point. So this is one diametrically opposite point. This you can take A point, this you can take B point. These are diametrically opposite point. So you have to find out the resistance. So you have to find out resistance between A and B point. What you will do? Like the same question, right? Previous question we did. For length L, the resistance is R. So if this is total length is L, you make it a circle, you will tell that this length will be how much? This length will be your L by 2. And similarly this length will be how much? Your L by 2. If this is L by 2, for R resistance, the length will be L. For L by 2, the resistance will be R by 2. This thing we have seen initially, right? And this is also R by 2. Got it or not? So you can make this connection like this. This is your point A, and from point A there is a resistance that will be R by 2, and here it is a resistance that is R by 2. This is your point B. So net resistance will be how much? This will be R by 2 into R by 2 divided by R by 2 plus R by 2. So you can say that this is coming as R by 4 ohm. Clear? This will be R by 4 ohm. Option number 1 will be correct. Right? So here what I use? For L length the resistance is R. For L by 2 the resistance will be R by 2. Because the cross sectional area and everything is same, because I know the formula resistance equal to rho L by A. Area is same, resistivity also same. So if length will be half, the resistance will be going to half. From this formula you can say. Clear? Now go to the next question. No, next question no. So we'll see now one more concept, that is open circuit and closed circuit. So basically, first of all, see the open circuit. In open circuit means there will be no current flow through this circuit. What it is saying that, let's say this is your a practical cell or real cell. This is EMF E and this is R, and you are not connecting here. This is open here. If this is open, then there will be no current will flow in it. So in open circuit, the current is 0. So you can say that here current is equal to 0. If you close this one, there will be a current flow. If it is open, there will be no current flow, right? That is called open circuit. So current flow will be 0 in open circuit, right? Now if I take this is point A and this is point B, you know that point A and point B are called as what? Terminals, right? Point A and B are called terminals. Now can you find out the difference between the potential at A and potential at B, that is terminal potential difference? So we will tell that we can write VA. I am going in this direction. If I am going in this direction, so this is your EMF. You are going from positive to negative. You are going from positive to negative. So if you are going from positive to negative, there will be minus E, that thing we have seen. And here the current is I, and that value is equal to 0. if the current is 0, basically here you can say that if the current along this direction, I am taking along this direction, the current is I and that current is 0. If the current is 0, there will be no potential drop across the internal resistance. So it will be V minus E, this will be 0, or you can write here this will be plus 0 into R is equal to your VB. So you can say that VA minus VB equal to your E, and this value is what? EMF of the your cell. This is your EMF, and you can say now that the terminal potential difference is equal to EMF of cell if it is a open circuit right. So EMF can be defined as terminal potential of the cell, terminal potential difference of the cell when it is a open circuit. Clear? Now there we will see short circuit. Another thing concept is short circuit. In short circuit, what will happen that this is one terminal A, and this is your EMF of the cell, this is your internal resistance, this is terminal B, right, and this one is connected like this. That means here the resistance of this wire is 0, right? This resistance is 0 and it is current is flowing I. In short circuit, it is directly connected to this. So instead of putting a wire, you can say that the A and B terminal is connected both. Got it or not? So if it is connected like this, you can say that potential at A, VA and VB are same, right? If it is connected, then VA and VB will be same. So VA equal to your VB. If I want to write down in this way, so this current is I, so what will say? So VA minus E plus I into R is equal to your VB. So VA minus VB equal to E minus IR. So this will be 0, this will be E minus IR. So I will be E by R, right? I will be E by R. Clear? This much you will get for short circuit. For short circuit means you are connecting a wire A to B, that means A and B are in same potential, or you can say that A and B are connected. If this is the case, there will be the current will be in the circuit will be EMF divided by internal resistance of the cell. Clear? These two things. Now see this problem. For a cell, terminal potential difference is 2.2 volt. When the circuit is open and reduces to 1.8 volt, the cell is connected to a resistance of 5 ohm. Right? Determine the internal resistance of the cell. So see here. The cell terminal potential difference is 2.2 volt when circuit is open. Circuit is open means what? The terminal potential difference is same as your EMF. So they are telling that EMF of the cell basically 2.2 volt. When the circuit is open and reduces to 1.8 volt when cell is connected to the resistance of 5 ohm. So it has a internal resistance small r, and now it is connected to a 5 ohm resistor, right? Now the terminal potential, this is VA and this is VB, it will be reduces to 1.8 volt. Clear? So I can say now this VA minus VB is equal to your 1.8 volt, right? Can you find out VA minus VB? You will say that VA minus VB is equal to E minus IR, right? E minus IR. So this will be 2.2 minus I into R is equal to 1.8 volt. So IR will be how much? 2.2 minus 1.8 will be 0.4 volt. This will be IR. Right? I have to find out the internal resistance, so I have to eliminate the current. How I will eliminate the current? So the current will be in this circuit. The current will be flow along this direction. Current will be how much? It will be 2.2 divided by 5 plus R, right? This thing you know. This will be 2.2 divided by EMF divided by R plus R, 5 plus R. Just put it here. So you will get, if you put it current value here in this equation, you will get 2.2 divided by 5 plus R into R is equal to 0.4. So this will be 2.2 R is equal to, this will be 5 into 4 will be 2, right? This will be your 2 plus 0.4 R. So this will be, you see here, this will be 2.2 R minus 0.4 R. It will be give you 1.8 R equal to 2. So R equal to 20 divided by 18. So this will be 10 by 9. Clear? So I have to find out this internal resistance and I got 10 by 9 ohm. How I will got? I just apply that VA minus VB equal to 1.8 volt, because see here, now the terminal potential is 1.8 volt, but they didn't tell the EMF of the cell is 2.2 volt. Indirectly they tell that EMF is 2.2 volt, right? They tell the terminal potential is 2.2 volt when it is open circuit, right? So you have to know by this language that they are telling about the EMF of the cell. Clear? Now go to the next question. So sorry, this will be 10.9, 10 by 9, right? So option 1 will be correct.